as Cyril has mentioned, traces are the what is going on, what is actually happening, how do we kind of dig into exactly what's happening. And most of you, I think, will find this fairly familiar. We're going to use Loki to start with. One of the classical ways of actually getting to traces is simply by using log information that's being printed out by your application, and then following the trace IDs that are printed out in your logs to get to a particular trace. The application that we've actually got here is a microservice application. I think Cheryl's going to put the link into the repository in the chat. It's the Intro to MLT repository that we've been using for the other two sessions as well. Very simply though, what I'm going to do is take the first part of our service. It's actually a three-part service. There's kind of a load balancer application, there's an API server application, and then there's a database application on the end. It's a three-tier service. And I'm going to get the logs from the load balancer essentially. And it's going to show me the requests that are coming in. So as we probably went over in the log session, very simply, we can look at the logs that are being stored in Loki in Grafana Explorer. We have a little diagram up here, visualization. But each of these log lines is in a log format. So we have a date, a key, equals, a value, so on and so forth. And as you'll notice in these particular log lines, we have an HTTP method. So this is the type of method request, REST API request that is coming into the load balancer, deletes, gets, posts, puts, so on and so forth. We have a particular endpoint that is coming in that is being hit. So these requests, this particular one wants to go to an owlbear, this wants to go to beholder, so on and so forth. And then we actually have two separate sets of log lines that are going on for each request. You'll notice that these trace IDs kind of the same for a few of these lines, and I'll explain why that is. The very first kind of log line that occurs is the duration. So this is when a request has come in, a response has been processed, a response has been gathered together, and a response has been sent back out to the requester. And this will give me a duration. So this tells me that this entire request for a get on beholder took 25 milliseconds. And in actual fact, it was of status success. So this went well. There are probably some failures down there. Oh yeah, we have a failure down here as well. So we have essentially just normal log events going on. And of course, I can click into these much as you saw in the logs presentation, and we can look at the labels that are on these Loki entries. And we can also look at the detected fields that are being detected from the log message itself. Now you'll immediately notice there's a little blue pill button down here. Because we have a trace ID, and because Grafana knows about logs, it knows about metrics, and it knows about traces, what we've done is we've configured our log setup, our log data source, to actually try and look for any trace IDs that might occur in a log. And if it finds one, it will present us a small pill button to go to Tempo. Now, if I click on that, I will immediately get to the trace that is corresponding and associated with the log line that was printed out. So when a request came into the load balancer, a trace was started, spans were collected as it went through all the downstream services, and when a response was sent, that trace was ended, and that's the point we actually printed out the log line. The trace ID itself is available from the OpenTelemetry instrumentation that we're using for this particular application. We just have some code that is also doing the instrumentation and has also decided that because it can get the trace ID, it will put it into a log entry. We'll go into auto instrumentation in the next demo and auto logging, which will kind of show you a little bit about how you don't need to actually put this information in your code yourself if you don't wish to. We're also going to come back to this trace in a second, but I just want to quickly show you how we actually configured Loki to derive a trace and a link to Tempo. So in many of our log data sources, including Tempo, Elastic, and a few others, we actually have this derived field setting. Now, this allows you to search through each log entry and determine whether there's something of interest in there. So in this particular case, we've added a derived field called trace ID, which uses a regular expression, and whenever it finds trace ID in the log message equals to a value, it will extract that value, as we have a capture group in this regular expression here, and it will use the raw value to send it to a particular data source. In this case, we've said it's an internal link to an internal data source, and that internal data source is Tempo. And this is what's producing the blue pill button for us. It's allowing us to go away, look at the line, extract the trace ID, and then send it to Tempo whenever it finds it. So very, very simple actually to set up if you wish to do so. So what we're going to do here is I'm going to start with the Tempo data source immediately. But just to quickly show you, you don't actually have to go to your logs data source to try and extract trace IDs. We have a series of different search functionalities up here. So I can actually go and, again, specifically search for a particular log entry from a particular job, and it will actually give me all of the trace IDs where this matches. So now I can instantly use the Tempo visualization panel to search Loki for those traces which I'm interested in. I can obviously click on one of those and bring this up again. There's also the functionality to search via spans. So for example, trace IDs are the usual way of searching. You might have a trace ID in log entry, but you also might be saying, well, in a particular case, I actually want to search for a set of traces via the spans that are in there. So as all spans have data on them, they usually include the service name. So I could select Mythical Requester. I can select a particular span name. All spans are named when you create them, even in auto instrumentation. So they're fairly unique, a set of names which you could also look for. But I'm going to look, for example, for any spans which have been flagged as a REST API status code error of 500 and which are at least 40 milliseconds long. So this would allow me to go away and get any erroring trace where there is a span with a status code of 500 on it, an internal server error, which is at least 40 milliseconds long. Maybe average requests take about 20 milliseconds, but I want to see all the ones that are taking 40 milliseconds. They're taking too long. And again, this has now allowed me to very quickly, let's just sort by duration, go from 40 milliseconds up. And again, this is the list of all of the traces that match, and I can look at them and visualize them. So that's essentially how you can use logging and Tempo itself to search for the traces that you might be interested in. Let's have a quick look at a full trace diagram within Grafana itself. So as you can see, up here at the top, we have kind of a trace view. This top little overview window here gives you a general idea of how long the trace itself is. In this case, it's 40.44 milliseconds. And it gives you a good idea of the breakdown of spans, how many spans, what their average durations are, what the longest ones are, etc. By very easily kind of giving you a little bit of a waterfall diagram here. We can then go down and actually look at the more advanced view. This is giving you each of the spans in detail. So as Cyril said, a trace is essentially an empty shell. It's made up of a load of spans. You have a single parent span, which is the first span in a trace. That might spawn other spans. It might call downstream services. It might create new spans to do that. These are child spans, and they kind of form the bulk of your trace. There might also be sibling spans, which are spans that happen at the same time. You might have two operations occurring in parallel, and therefore you might have two spans that are occurring at the same time, but they may have their own children that carry on and do other things. We can actually look at any of these spans by expanding them, and we can go and have a look at all of the metadata that Cyril was talking about as well. The very basic thing that every span has in common is that it has a service name, and then it has a set of additional tags or attributes, which actually always pertain to the work, the operations that are going on that generated that particular span. So for example, in the Express middleware, we might have a span that details the types of headers that were in there, the types of requests that came in, that kind of thing. In this particular thing, we're doing the same kind of thing. There's a post to an endpoint. So we're being told what type of HTTP flavor it is, i.e. it's HTTP 1.1. We're being told the host that was actually hit to create this post, the method, what the length of the head, the request content was and compressed, so on and so forth, and the HTTP target. Other spans might contain other information pertaining to the particular job that they're doing. A good example of this is that we're also talking to a Postgres service underneath a database. And in this particular span, we have all the information that is detailing how we're doing that. So the connection string to the underlying database, the database name itself, the database statement that is occurring, the system, the user, so on and so forth. And this allows you to get very quickly into any of the spans that can form your trace and actually allow you to get detail into these. As I say, all of these spans can essentially combine to create your trace. And the final thing to kind of notice about just this quick overview is that we obviously have two sets of colors here. We have green and we have a kind of a yellowy orange. And these actually denote the two different services that comprise our application. So distributed tracing is the act of following a data request, a data process, some data flow between the start of a request and the very end of a request. And this might go through several services. In this case, we're going through two different services here before it hits the database. And we denote those two different services, the load balancer and the API service endpoint, by green for the load balancer and yellowy orange for the service. And this very quickly allows you to see where the bulk of the work is being done. We are waiting for a request here at the top of the load balancer, which gets handed off to the service, the API server underneath. And once that has done all its work and it's formed a response, it then sends it back to the load balancer, which will then send it on to the requester. The other thing to quickly note is, of course, the top bar here is the request and the response back to the initial user. And you might be thinking, well, hang on, why isn't that actually 44.4 milliseconds? Why isn't that the entire length of the trace? Well, the reason for this is there might be other work going on. So even though a response has been sent back to the requester, there might actually be other work that has to go on to actually clean up after the service itself. It might have been making other calls to databases or other things. And this is why the trace is continuing, because the spans that have been created here have been part of the knock-on process of actually creating that request response and that trace. Just a couple of other things to notice is that, as Cyril said, we have a node graph. So this allows you very quickly to see kind of like the topology of how the spans are actually created. We have our parent span here, which called out to two other points in mythical request of the same load balancer. These are actually logging to Loki, but it also called out to the service, the API service underneath downstream. This is the post here, and it itself called out to several different systems, including the database, which I can't quite see here. I can zoom in a little bit. Yes, here, down here, and that in itself knocked on and carried out several work after a response came from the database. So you can very quickly get an idea of how spans actually work from a topological map kind of view. Also worth noting is that green spans take slightly less time to process than yellow spans or red spans. So it also gives you an idea of the amount of time each span took. Finally, although it's not going to be very exciting, we can get an actual service map as well. So this shows you all of the different services, i.e. the load balancer and the API endpoint server in your system. There's only two here, so it's not very exciting. But essentially, that's a quick overview of how to get from a set of logs to a set of traces, drill into a trace, and look how that trace is comprised.